As we have discussed earlier, every physics book adapts a particular sequence between the chapters, and they always maintains it. Because between the three branches of mechanics, relativistic mechanics and quantum mechanics is not in your syllabus. So we have to start with classical mechanics, and as we are dealing with the motion of solid bodies, we need to study dynamics. Now between the two branches of dynamics, that is kinetics and kinematics, kinematics is the more easier one as it is implied by his name, because kine means motion and matics mean math. Hence we need to find only the parameter related to motion only. We do not need to find the cause, that is force, responsible for the motion. Hence we will start with kinematics. So we will have kinematics as our first module. This kinematics will be divided into three chapters. The first one is one dimensional motion or 1D motion or rectilinear motion, as the motion is always occurring along a particular straight line. The second chapter will be two-dimensional motion or 2D motion or motion in space. Now third chapter will be three-dimensional motion or 3D motion or motion in space. However, for motion in space, we will only deal with its numerical problem. But between one-dimensional motion and two-dimensional motion, we will have vector as our second chapter. So this one will be our first chapter, vector will be our second chapter, and this one will be our third chapter in the module kinematics. Because during the study of one-dimensional motion, it is quite easy to denote or represent the direction in which the particle or body is moving, as it can move only along forward or backward direction, right or left, up or down. So if we consider one direction to be positive, then other will be a negative one. However, when we are discussing two or three dimensional motion, we need special kind of math for handling the direction in which the particle is moving, and that is a vector. Hence we will have vector as our second chapter and two-dimensional motion as our third chapter. Now once we have masters at the art of measuring of motion of a particle and expressing it, we will move to the reason behind the motion. So we have Newton's laws of dynamics as our second module. Now in this module, we will have a clear idea about force both in qualitative and quantitative manner, and find some of the properties of force, and we will have idea about frictional force, gravitational force. We will find a separate formula for finding the gravitational force, which is proposed by also Newton, and pseudo force. Now after this, we will modify Newton's law in the context of energy, and simplest way of changing energy from one form to another, that is work. So energy and work energy will be our third module. We will do this modification of Newton's law in the context of energy and work by using conservation of energy, conservation of work, and conservation of linear momentum. Now in all the above chapters, whatever analysis we are doing, we are performing it by considering it to be a particle. The body, we are considering the body to be a particle, because all the above law is stated for a particle or point object, and we will not face any difficulty for assuming the body in, that means the body which is undergoing motion, to be a particle, because in most of the cases the distance traveled by the body is much more larger than the dimension of the body. Like in the previous example, we have two stations which is situated say 120 km apart, which is very much greater than the length of the train. Hence we do not need to differentiate between the tip and the last point, that is the toe of train. So we can say that the dimension of object, that means the object which is in motion, is irrelevant to the distance we are concerned with. Also in all the above cases, we are dealing with a rigid body. Hence we can say all the constituent particles of body in same direction and with same velocity. Now this happens as we are dealing with a rigid body, so the force applied over it will not deform it, so every point of it move in same direction and with the same velocity. But for practical purpose, we need to take up the study of rigid body, that means rigid extended bodies. Hence next module will be study of motion of rigid extended bodies. Now for an extended body, there can be two types of motion. First one is translation, and the second one is rotation. Although these two motion occur simultaneously in a body, but for the sake of simplicity of analysis, we will find it into two different chapters. Analysis of this translation motion can be done by defining a mathematical point inside or outside of body known as center of mass. Once we found it, we can now apply all the laws that we have developed previously as it is a point, and we know that we can apply every kind of law for that means the law which we have developed in previous chapter to a point. But here at first we need to prove that the motion of this point is equivalent to the motion of body. Now after this we will find rotational motion, and we see certain parameter related to rotational motion like torque, couple, angular momentum, moment of inertia, etc. And we will redefine Newton's laws for rotation using these parameters. Now we are all done with motion of a particle and extended bodies. So it is time to find out the response of a body on application of external force. That is what happens when a force deforms a solid body. And we will see it in the context of elasticity and plasticity. We also find reactional force that developed inside a body due to the application of external force. We will call it to be stress. We will define all of this in terms of pressure in case of a fluid. Here in this chapter we will going to have some idea about fluid statics and find some laws. So we will find some laws governing pressure and also find a way to measure pressure. After this we will study some of the properties of matter like viscosity, surface tension, and all of these properties are known as properties of bulk matter. All of these properties we will find in a completely separate module known as properties of bulk matter. So all of this topic we will find in a separate module called properties of bulk matter. Properties are known as bulk properties of matter as all of these properties arises with when the matter appears as bulk, although we will find another property which is also arises when matter appears in bulk, and that is heat. We will find it into a separate module. As we know it to be the manifestation, that is heat is the manifestation of kinetic energy of molecules of bodies, and find out the ways in which heat can transfer from one place to another. After this, in next module we will try to find a way in which we can convert heat into work as this is the basic of all heat engines, or try to get work out of heat or heat out of work, and we will do by using it first and second laws of thermodynamics, and we will find all of this into a separate module known as thermodynamics. So after all of this, we will apply the laws of dynamics, conservation of energy, linear momentum to find out the motion of molecules due to which it gives pressure in a container in a completely separate chapter known as kinetic theory of gases. We will also find properties of gases in this chapter. So properties of gases will also be discussed in this module. So these are the modules we are going to study, and all of these modules is given in this particular sequence in any physics book.